IUPAC Nomenclature of Coordination Compounds. Square bracket always represents the coordination sphere. Chromium, NH3 thrice, H2O thrice, Cl3. Now, as per the rule, we should name the cation first. So this is the complex cation. Complex cation. Complex cation.
Okay, sir.
And this is the anion. So the cation should be named first. And within the complex ion, that is the coordination sphere. Within the coordination sphere, neutral molecules first, followed by other ligands. Here there are two ligands. One is ammonia ligand, another is water ligand. Both of them are neutral ligands. So in such cases, you can name the ligands in an alphabetical order. So this is amine, double M. This is aqua, water. So this should be named first. Triamine. So triamine, double M, INE. Triamine. And then aqua. And what about this? This is triaqua. So triaqua. Okay, triaqua. And then chromium. So chromium. Now we have to judge the oxidation number of the central metal atom. Chromium is the central metal atom. So here chlorine, we know this is -1. If it is -1, it has got 3 chlorine, means it should have plus. So +3 is the oxidation state of the complex ion. And these two are neutral ligands. So the chromium should have +3 oxidation state. Are you able to follow? You can work out algebraically also. Put X for chromium. And there are zero charge of ammonia. So 0 plus 0 for water is equal to +3. It means X is equal to +3. So chromium has 3 oxidation state, +3 oxidation state, and that should be represented as Roman letter 3. And then chloride, CHLORIDE, chloride. Okay, so this is the name of this complex compound. Shall we try the next one? Second. Cobalt, NH2, CH2, CH2, NH2. Thrice, and then this is twice, then SO4 thrice. Okay, so here the complex ion is cation. So complex cation. So this should be named first, and before that let us judge the oxidation number of this one. We know for sulfate -2, and for this we do not know, put X. So you had twice the X, is it not? Okay, so the charge is X, so 2X plus, and the sulfate is 3 of minus 2 is equal to 0. So 2x is equal to plus 6. So x is equal to plus 3. So the x is 3. And this is neutral molecule, which is nothing but ethylene diamine. So the cobalt should have plus 3 oxidation state. So it can be represented as 3 Roman letter. Now what about this? This is a bidentate ligand, ethylene diamine. And this should be called when it is multiplied by 3, or when there are 3 or 4. Here the atomicity of this one is 3. So tris, it should be called a tris. So tris, and then what is IUPAC name of this one, ethylene diamine? Ethane. This is ethane 1,2-diamine. Okay. So you can start like this. Tris. There are 3 times of, then ethane diamine. We have to show it by bracket. Ethane. Okay. And then 1,2-diamine. And single M. In the case of ammonia, double M. In the case of amine, single M, diamine. Close the bracket. Then you are left with cobalt. So you can use cobalt, and its oxidation state is 3. So cobalt 3, and then sulfate. So sulfate. Okay. Got it? What's the doubt? So let me explain about this ethylene diamine. CH2 double bond CH2. This is ethylene. IUPAC is ethene. Okay. Diamine means CH2 single bond CH2. Here you have one NH2. On other side you have another NH2. This is called ethylene diamine. Okay. And its IUPAC is, this is ethane 1,2-diamine. Okay. So ethane 1,2-diamine. Okay. This is the IUPAC. And this is available as ligand 3 times. So it's a bidentate ligand, but available around the cobalt 3 times. Okay. So it should be called a tris. Why it cannot be called tri? You will get a confusion. Suppose if it is 2 means you will call it di. When I say diethane 1,2-diamine means there will be a confusion. So in order to be specific about this ligand, which is having the polydentate type, okay, and usually they form chelate complexes, ring complexes, okay. So we have to name like this one. So for didentate, polydentate, especially for naming polydentate ligands, you have to use the strategy. If it is twice, you have to call it bis, not bi or di. If it is 3, tris. If it is 4, tetrakis. It is 5, pentakis. Likewise it goes. Okay, teta. Let us proceed to the next compound. Ag, that is silver. NH3, ammonia ligand, neutral compound, neutral ligand. And AgCN twice. Now, you have here two complex ions. The first complex ion is complex cation. The second is complex anion. So let us proceed with the first complex ion. Within the coordination sphere, you have to identify the central metal atom, that is silver. And what about this one? Ammonia. And how many ammonia ligands? 2 ligands. So diamine silver. Double M. Amine silver. And then let us give the oxidation state. So both of them are of 1:1 ratio. So the oxidation state must be, this is neutral. So in that case, silver is 1. And anion. Within the anion, complex ion, name the ligand first. Cyanido. So dicyanido. So dicyanido. And you cannot call it silver because complex anions should be ended with or concluded with ate suffix. So you cannot call it silverate. You must add the suffix ate with the original Latin or Greek root name. So we have the argentum, that is silver argentate. So dicyanido argentate. Do you understand this? And give the oxidation state of that central metal atom, that is 1. Okay. Next one. So here both cation and anion are complex nature. K4 FeCN 6 times. So here complex ion is anion. So it should be started with cation, potassium. And here you have potassium K4. And what is the oxidation state of complex ion? -4. Okay. So FeCN 6 times of 4 -4. Because K is plus. So 4 times, 4 plus. So it should be compensated by 4 minus. So the charge of complex ion is -4. And for cyanide it is -1. So put X for this. So X plus 6 of -1 is equal to -4. So X minus 6 is equal to -4. X is equal to -4 plus 6. So plus 2 is the oxidation state of iron. So this is 2. Now let us give the name potassium. And then hexacyano, cyanido, cyanido, ferrate, 2. Okay. In fact, you have to continuously give the name. You should not leave the gap for the complex ion. Hexacyanido, ferrate, continuously should come. Got it?